Welcome back, guys. Today we are taking a break to solve a couple CTF challenges from OverTheWire wargame site. Specifically, we're going to continue with Natas web security challenges. These are web security challenges or web security CTF challenges that you can go over to improve your web security skills. So in previous videos, we went over level 0 all the way and we reached level 7. In this video, we're gonna go over level 7 to 8, 8 to 9, and 9 to 10. So to start with, we're gonna now go take this URL and this is what we see when we navigate to the URL. So basically, as you can see, we have an input box, and once we submit something, it's supposed to check if the inputs we provided matches the secret. Of course, there's a secret whereby the input is matched, and if it matches, it will display the password. If it doesn't, it will just do nothing. Let's say, for example, DD submit. As you can see, wrong secret. So let's take a look at the source code and understand how this works. So this is all HTML. We're not gonna take a look at this. So we start with the variable encoded secret, and we have an encoded value. Next, we have a function called encode secret. Takes secret as an argument, and the function, what it does actually, first it base64 encodes the secret, okay, and then it does string reverse. String reverse in PHP is a function that reverses the order of a given string. For example, if it is 3D, if it starts with 3D and ends with 62, when we subject the string to the string reverse, it's gonna instead start with 62 and ends with 3D. Next, after it does base64 and reverses the string, it does binary to hex. And that's how the function encode secret works. Next, we have another function called array key exists. It takes our input into post request. So what it does, it actually compares the input we provided, right, to the encoded secret. If they are equal, it's gonna say access granted. The password for Natas is password. If it doesn't match with the encoded secret here, it's gonna say wrong secret. So you might be saying, why don't we provide the encoded secret right away here? So copy that and try with it. But we still get wrong secret. So why is that? Basically because the encoded secret here undergoes the conversions we have here by the encode secret function. Let's take a look now at how this is called. This function is called. So in the form here, form method equal post input secret type submit form, and lastly we have the HTML elements. So basically what happens here is that, yeah, that's right, we can provide the encoded secret, but once we call the encode secret function on the input we provided, it's gonna call this function and perform these conversions on the secret. So if you want to match the encoded secret, we're gonna need to perform the same operation here, but in reverse order. So we're gonna do base64 encode, string reverse, and lastly binary hex. So that's how we're gonna approach this challenge. But remember that we need to do that in PHP. So basically we're going to PHP interactive mode in order to apply these functions on the secret. So we have the encoded secret here, right? If we perform the reverse, as I told you first, we base64 encode, string reverse, and binary to hex, we're going to get the original secret. Let's try this. So here we enter the PHP interactive mode, php-a, and now we use echo base64. We start with base64 decode, and then the next function string reverse, and then we put hex to binary. This is the order of the functions. Next, we put in here the encoded secret we have. So if we go back now and grab this, Okay, now we have 3 parentheses, 1, 2, 3, and lastly the semicolon. So as you can see, we get now the secret in the original form. We're going to copy that and then provide it. So what's going to happen now, once I provide this in the post request, what's going to happen, as you can see, it gets into the if statement. After it enters the if statement, this is my secret, right, that I provide from here. It's going to be, oh, okay. So it takes the secret I provide, it calls the encode secret function on it. It's going to perform the binary to hex, then string reverse, then base64 encode. And it's going to end up equal to this one. Because what we just did, we reversed the order of the operation from base64, string reverse, binary to hex. Originally, it works like that: binary to hex, string reverse, and base64 encode. And ends up being equal to encoded secrets. That's why we're going to get now access granted. Let's try that. And we were right. So this is the password for Natas 9. Grab this password, put it on the side, and now up to level 9. So this is the URL. Right, we have the password. Natas 9. Alright, so again we have an input box. Find words containing. Let's take a look at the source code, see how this works. These are the HTML elements, no need to bother with these. So we start from here. We have the key equal to nothing. Then we have an if statement. The if statement compares the request with needle. If now the key equal to the needle, what's going to happen? Okay, next we have key not equal to nothing. We have the pass-through here. So the pass-through is actually a PHP function. And what it does, it actually executes grep, a system command in Linux. So this pauses the possibility of doing command injection. Since we use now a command here, grep, right, without any sort of input validation, as you can see, the key here is taken right from the post request here. So we assign the key to the value of the parameter or the value of the string we provide into post request, assigned to needle and then to the key. And then if the key exists, what's going to happen now? It's going to take the key we provide and use a grep on this. So this command in grep-i key dictionary.text, what's going to happen? It's going to look for the occurrences. It's going to look for the occurrences of the string I provide in the dictionary.text using the grep and the pass-through function. So what I can do here, instead of the key, or I can provide any letter like C or B to look for this letter in the dictionary.text, and then I can execute another command. Let's see this now. So instead of key, we'd go back and say, for example, B, okay, and then we put here semicolon to indicate that we want to execute another command. Okay, now the other command will be here to display the password of the next user. The next user is Natas 9 or is it Natas 10? So here cat etc Natas web pass. By the way, you can find the directory that holds all the passwords from this node. So etc web pass and Natas 10, I guess. Okay, let's see now. And we get the password, as you can see. So what happened here, we sent P, right? And then after P, we appended the semicolon to indicate that we would like to execute another command. Since there is no validation on the input we provide, as we saw earlier in the code, it's going to then execute this command, which displays the password of Natas 10. So up to the next level now. Level 9 to 10, we solved that. Level 9 to 10, yeah, Natas 10 here. So this is the password. All right. So for security reasons, we now filter on certain characters. So this one is the same as the last one, except that it filters the input. So our input is subjected now to a filtering mechanism where it is filtered against a whitelist or a blacklist. Let's take a look now at how this happens. View source code. This is the key, and then here we assign the post request value to the key. That's we got this. Now here you go. This is the if statement. First, as you can see, we make sure that we provided the code. Make sure that we provided the value in the input. Then, if it's provided, it's gonna subject the key to a comparison mechanism through the break match function against this list. So if the request or if the value we provide contains one of these characters, the /, the square bracket, and then the semicolon, pipe, ampersand, it's gonna reject our input. So print input contains illegal characters. Else, if our input doesn't contain at least one of these characters, it's gonna say, or it's gonna now perform the pass-through function in a safe manner as the developer thought. And then it's gonna take the key and use it as an argument for the grep command. So in order to get to this point, as we did in the previous attempt, we're gonna need to bypass this list. So how to do this? Basically, there is no way to bypass this list to execute another commands unless we take a look again at this line. So this line contains the grep command, and in grep there is a way to display the location and the contents of every file. So the grep command, what it does here, it takes the input, say it's B, right, and then it's gonna look for the character B, all the occurrences in the dictionary.txt. What can we do here? We can, instead of key, we can provide let's say an argument in grep so that it reveals the location on the contents of all of the characters we provide. To take a look at this, we can go to grep manual, and let's see here. Where can we find this? So grep let's search for this. There you go. So here's an example command that invokes GNU grep. This lists all the lines in the files menu.h and main.c that contain the string hello. Right? Again, take a look at this one. So here, f dot asterisk, and then we have \c. So if we use this formula, what's gonna happen now? Grep will look for all of the occurrences, right, in this file. For example, what's gonna do? It's gonna look for all the occurrences where it starts with the word or the letter F, and it ends with the .c in the current working directory. So the key here is that we use dot asterisk, right? Dot asterisk. So once we use dot asterisk, we can prepend this one with a letter to indicate that we want to look for all occurrences or all the contents where it starts with F, for example, and ends with .c. We can even leave these empty, indicating that we want to display the location and the contents of every single file that contains our pattern. So we can go back here. So what we do here, look, for example, we can type F, right? So we want to display the contents and locations of all the files that contain lines that would start with F. How to do that? We say first F, then dot asterisk, right? That's it. And then we put space. After that, we execute the command that we want to, which we want to provide to reveal the contents of the next user password. So cat. This one is a bit I'm not gonna say hard. It's just like, you know, I can't find the word for this, but you know, you got what I mean. So etc Natas web pass Natas 11. Let's see if this works, and let's take a look at the output. As you can see, we were able to grab the password for Natas 11. But how about these? Why all of this were returned back to as an output? So let's take a look again at what we supplied. So F, as you can see, all of the output contains the word F. This one starts with F, 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 because the pattern we use is like this: F and then dot asterisk, right? So this one will look for all of the occurrences in all of the locations in the current working directory, and displays the output back, right? So this is the password for Natas 11. So we're gonna stop here now, and in the next video we're gonna go over Natas 11 to see what we have to do. Thank you for watching, and see you in the next video.